it's 371. Let's go ahead and get started. Alright, let's take a look at number 43. Ignore the directions for all of these. Just simply simplify all the problems as far as they can go. So here we go. We're multiplying two radicals. You know what to do. In order to multiply two radicals together, they must have a common index. They do. We have a cubed root for both of those. So the cubed root of, now we can multiply 1 times 1. I'm not going to worry about that. 14 times 13 is 182. And now let's see if we can simplify that very quickly. 2 goes into it 91 times, and 91 is prime. So 2 times 91, I'm looking for sets of 3 numbers are the same. I don't have any, so this is my answer. Number 44. Okay, I'm multiplying two radicals together. They must have a common index, and they do. So I have the 8th root of 15. Nothing I can do. If you break down 15, you get 3 times 5. I'm looking for numbers that come in sets of 8. There's no way I have that, so my answer is 8. The 8th root of 15, number 45. Sorry, students, excuse me. Okay, students, on number 45, we have the, actually, we can write it, if you would like to, as the 4th root of 6 times the 5th root of 6 to the 4th, but then we would not have matching indexes, so I could not multiply. Do you see that? Okay, an index of 4 and an index of 5. So I'm just going to go ahead and do this. I'm multiplying like bases. So write your like base ones and then add these two fractions together. 1/4 plus 4/5 gives you 21 over 20. So we have 6 to the 21 over 20 power. Now you could write it like this if you wanted to. The 20th root of 6 to the 21. Alright, you could do that. And actually you could simplify it, because think about it, guys. If you have 6 to the 21, that means you'd write out how many 6s? 21 6s, right? And you're looking for sets of 20, so really you could cross off 20 6s, put 1 6 on the outside, and you're left with 1 on the inside. Okay? But the reason I'm not going to do that, remember, your original problem was written as rational exponents, so your final answer should be written as rational exponents. Okay? Moving on to 46. Okay, now we have a power raised to a power. Some of these are a little repetitive, using yesterday's information, but that's fine. A power raised to a power, you multiply them. So 6 7 times 1/2 would be 6 over 14, which reduces to 3 7ths. So 5 to the 3 7ths power. Now again, you could write it like this, the 7th root of 5 to the 3rd, but your original problem was not written with a radical, it was written with rational exponents. So your answer should be written with rational exponents also. Okay? Alright, moving on. Number 47. Same thing here, guys. We have a power raised to a power. So I have negative 3 times 5/3. That's going to be negative 5. Okay? Negative 3 times 5/3. Now, we don't want our final answer to have a negative exponent, so we put this over 1, and we bring the 6 and the 5 down to the bottom. You don't bring the 1 up top, because the 1 has a positive exponent of positive 1. So now I have nothing left up top, so I'll put a 1 in the bottom. I have 6 to the 5th times what was already down there, a 1. So my answer is 1 over 6 to the 5th. If you wanted to put 1 over 7,776, that's fine. I don't mind that, but this is fine also. Okay? Alright, moving on to number 48. Okay, we're going to multiply like bases. So, write your like base once, right? When you're multiplying like bases, write your like base once and add the exponents. So we have 1/8 plus 3/5, and that's going to give us 29 over 40. use a calculator if you need to, okay? 29 over 40. Now, yes, we could write it like this. The 40th root of 3 to the 29th power, okay? And by the way, you could not simplify that because you would have how many 3's written out here? 29. And you're looking for sets of 40. Alright? So, and plus, you want your original problem had rational exponents, and so you want your answer to have rational exponents also. Alright, number 49. Okay, here we go. Same thing, first of all, I'm multiplying like bases inside the parentheses. So I write my like base once, add my exponents. 1/4 plus 4/5 would give me 21 over 20. And I've still got a 1/7 on the outside. When you're multiplying like bases, write the base once, add the exponents. Now, 21 over 20 times 1/7 would give you, when a power is raised to a power, you multiply your exponents. You'll get 3 over 20. Alright? 3 over 20. Now again, you're welcome to write the 20th root of 6 to the 3rd, but your original problem was written with rational exponents, so your answer should be written with rational exponents. Number 50. Same thing again. Inside the parentheses, we're multiplying like bases, so write the like base once, add the exponents, okay? So we have 5/7 being added to, what's the other one? 4/3. And you're going to get 43 over 21. Now all of that is being raised to the 3/5 power. Alright, so now whenever a power is being raised to a power, you multiply the exponents together, and we're going to get 43 over 35. Okay, 43 over 35. Now, your original problems were written with rational exponents, so this is going to be your final answer. However, I do want to point out to you, you could simplify this in radical form. Your index is 35. You have 2 to the what? 43. So you'd have how many 2's written out here? 43. And you're looking for sets of 35. So you'd cross off 35 2's and put 1 2 on the outside. And if you crossed off 35 2's, how many 2's would that leave you in here? Well, 8, because you have 43. So if you were writing this in radical form, you could not leave it like this. You'd have to leave it like this, okay? But we're not writing it in radical form, so it doesn't matter. But I'm still pointing that out to you to help you see that. Alright, same thing here. We're multiplying like bases, so we're going to add the exponents. 1/2 plus 2/3 is going to be 7/6. And we're going to raise that to the 1/6 power. So we'd have 9 to the 7/36 power, okay? And that would be your answer. You would not write it in radical form because your original problem was in rational exponential form. Number 52, same thing again. When you're multiplying like bases, write the base once and then add the exponents, okay? I did this in my head. I think you're going to get 21 over 15. Let me check that real quick. I'm probably wrong. 11 over 15, so I'm glad I checked that. 5, 6, yeah, 11 over 15. Okay, so you get 5 to the 11/15s. When you add your exponents, all of that's being raised to the 3/2 power. So when a power is being raised to a power, you multiply the exponents together, you'll get 11/10, okay? And so you leave your answer like that because your original problem is in rational exponential form. Okay, moving on to 53. Alright, now we're going to simplify the 5th root of 11 times the 5th root of 11 times 14. Now we probably won't be able to do a lot with this, but let's go ahead and figure it out here real quick, okay? Really what we're trying to simplify here is 11 times 14, which is 154. Okay, so the 5th root of 11 times 14 is the same thing as the 5th root of 154. Now we're going to break that down and try to find some prime factors, okay? 77 11 will go into 77. 11's prime 7 times. So the prime numbers are 2, 11, and 7. I'm looking for numbers that come in sets of 5. I don't see any. So this is your final answer. Alright, same thing here. The fifth root of 3 times 160 is the same thing as the fifth root of 480. Alright, so let's very quickly find the prime factors of 480. That would be 240, 120, 60, 30, 15, 3, and a 5. So how many 2's do we have? We have 6. No, we have 5 2's. So the fifth root of 2 to the 5th power times 3 times 5. So I'm looking for numbers that come in sets of 5. And I see one right here. I have 5 2's. So cross off one set, put 1 2 on the outside. Your final answer is 2. Fifth root of what? 15. Hope that makes sense, guys. Moving on. 55. Okay. We're going to add 2 radicals now. In order to add 2 radicals, you must have common indexes, and we do. And common radicands, and we do. So we add the outside numbers. 1 plus 4. So 5, fourth root of 5. And we cannot simplify that any further. 5's already prime. Okay, same thing again. I'm adding 2 radicals. Anytime you're adding or subtracting radicals, you want common indexes. I have that. You want common radicands. I have that. So simply add the outside numbers 1 and 6. 7, seventh root of 7. 7, seventh root of 7. You cannot simplify that. 7's already prime. And that's as far as we can go. Okay. I'm subtracting 2 radicals. Anytime you're adding or subtracting radicals, you must have common indexes, and we do. And you must have common radicands, and we do. So here we go. 4 negative 6 is negative 2. And then everything else stays the same. And that's as far as you can simplify this, because think about it. The prime factors of 6 would be 2 and 3. And you're looking for numbers that come in sets of 9. And there are no sets of 9's. So this would be your answer right here. Negative 2. 9th root of 6. Alright, number 58. Alright, I'm combining or adding 2 radicals here. Do they have common indexes? Yes. Do they have common radicands? Yes. So combine your outside numbers. A negative 3 and a positive 10 is going to give you a positive 7. 5th root of 2. Positive 7, 5th root of 2. Okay. Alright, moving on to 59. Now here, we're subtracting 2 radicals. We do have common radicand indexes, but we do not have common radicands. So let's simplify this one and see what we can do with this, okay? 768, 2 goes into it. 384 times, let's see, is that right? 2 goes into this 192. 2 goes into this 96 times. 2 goes into this 48 times. 2 goes into this 24. 2 goes into this 12 times. 2 goes into 12 6 times. And then 2 and then 3. So I have 1, 2, 3, 4, 5, 6, 7, 8 2's and a 3. So I'm going to do this. I'm going to put 2 to the 8th power times 3. Now guys, come on, think about this. That means I have 8 2's, right? So really I could have written 2 to the 4th power, that's 4 2's. 2 to the 4th power, that's 4 2's. And then my 3, couldn't I? Here's 4 2's. So 2 to the 4th, and then 4 2's. That's 2 to the 4th and 3. Every time I cross off a set, I put one number on the outside. Cross off a set, put a 2. Cross off a set, put a 2. Multiply them. So 4, 4th root of 3, minus 3, 4th root of 3. Now I have common indexes, and I have common radicands. 4 minus 3 is 1. You do not need to put the 1 if you don't want to, but you can if you want to. And there's your final answer. Alright, moving on now to number 60. Alright, same thing. I'm adding 2 radicals. I have a common index, but I don't have a common radicand. Let's break 48 down and see what we get, okay? 2 goes into it 24. 2 goes into it 12 times. 2 goes into it 6 times. outside. 2 cubed root of, now what's left over? 2 and 3 is up at 6. Bring down your cube root of 6 over here. And look at that. We now have matching radicands and matching indexes. So combine your outside numbers. 3 cubed root of 6. You cannot simplify this because the prime factors of 6 would be 2 and 3. So there's your answer. Moving on to number 61. Okay, I have common indexes but not common radicands. So let's break down 270, okay? The prime factors of 270, 135. 3 goes into that 45 times. 3 goes into 45 15 times. And then 3 goes into 15 5 times. I have 3 3s. I'm going to go ahead and do a lot of my work over here. Not because I'm trying to rush. I'm just trying to save time and do problems as efficiently as possible. So look, I know I'm looking for sets of 3 numbers. Well, I have 3 3s, so cross off 3 3s, put 1 3 on the outside. You're left over with a 2 and a 5. Multiply those together and you get 10. And then positive 2 cubed root of 10. So now we have matching indexes and matching radicands. Outside numbers are positive 3 and positive 2. That would be 5 cubed root of 10. And you cannot simplify that any further. 62. Okay, we're going to subtract a couple radicals. So they do not have matching radicands. Let's break down the 112 and see what happens. 2 goes into a 56, 2 goes into 56, 28, 2 goes into 28, 14, 2, and a 7. Now I'm looking for sets of 3. Okay? Well, I see 3 2s here, so cross off 3 2s, put a 2 on the outside, and I'm left over with a 2 and a 7 on the inside. Bring down your negative sign, bring down your cubed root of 14, okay? There's a 1 here, so 1 negative 2 is negative 1 cubed root of 14. Now if you don't want to put the 1, you can just put negative cubed root of 14. Either one of those 2 answers would be acceptable. Alright. Okay, number 73. We're going to combine these 2 radicals. We've got to simplify 1,701. Okay, now 2 doesn't go into it, but 3 does. I know that because 1 plus 0 plus 7 plus 1 is 9, and 3 goes into 9. That works for 3 and 9. Although we would never use 9 because 9's not prime, but still. Okay, so 3 goes into this 567 times. 3 goes into this number once, 189. 3 goes into this 63 times. 3 goes into this 21 times. And 3 goes into this 7 times. So I'm looking for sets of 5 numbers. Look here, I have 5 3s. 1, 2, 3, 4, 5. So cross off 3. Cross off 5 3s, put a 3 on the outside, and you're left with 5. 3 times the 5th root of 7 plus 4 times the 5th root of 7. Your indexes match, your radicands match. Add your outside numbers, and you get 7 5th root of 7. Moving on to 64. Okay, notice the radicands don't match. Let's take 176 and break it down. 2 goes into it 88 times, 2 goes into this 44 times, 2 goes into this 22 times, 2 goes into this 11 times. Now, I'm looking for sets of 4, and look at this, I have 4 2s, so cross off 4 2s, put 1 2 on the outside. There's already a 2 on the outside, and I'm left over with 1 on the inside. 11. Positive 5 times the 4th root of 11. Now, 2 times 2 is 4, so I really have a 4 outside here. Positive 4, positive 5, that's positive 9. 4th root of 11, 9 times the 4th root of 11. Number 65. Okay, let's break down both of these numbers. Okay, so 160, the prime factors of that would be 2 goes into that 80, 2 goes into that 40, 2 goes into that 20, 2 goes into a 10, and then 2 and 5. So I'm looking for sets of 5, and I have 5 2s right here. So write 1 2 on the outside, and you're left over with a 5 on the inside. Now, let's break down 1,215. Alright? Well, 5 goes into this, I know that 5's prime. So, 245, 5 would go into on Facebook at all? Are you on Facebook at all? Hey students, hold on 1 second here, guys. Okay, sorry about that. I was talking to my son. Okay, here we go. Now, I found my mistake. This will be 243. So sorry about that, guys. 243. So 5 goes into this 243 times. And now we can use 3. That would go into it 81 times. 3, 27. 3, that would be a 9, and 3, and 3. So look, we have 5 threes, and we're looking for sets of 5. So we have 5 threes, put a 3 on the outside, bring down your negative sign, put a 3 on the outside, and we're left over with a 5 on the inside. So 2 negative 3 is negative 1, fifth root of 5. And if you don't want to put the negative 1, then you do not have to. Alright, moving on to 66. Okay, let's break down both numbers. We'll start with 375. 5 goes into this. See, 35, 25, 5 would go into that 15 times, and 5 would go into that 3 times. Now, we're dealing with cubed roots, so we're looking for sets of 3. We have 3 5s, so cross off 3 5s, put 1 5 on the outside, and you're left over with 3 on the inside. Plus, and now 81. 3 would go into 81 27 times, and 3 would go into 27 9 times, and then 3, and then 3. Now, we're looking for sets of 3, so we're going to cross off that mess up again. Let's see if I did here. No, did not. So we're looking for sets of 3, cross off 3 3s, put a 3 on the outside, and then we're dealing with cubed root of what's left over, a 3. So my indexes match, my radicands match, positive 5, positive 3, positive 8, cubed